Hey, how you doing? My name's Elton and welcome to the show. So if you're new to the show, hi, this is my weekly container talk where I go through all sorts of interesting things, hopefully about Docker and Kubernetes and the ecosystem and architecture and all that sort of stuff. Really simple format. Every month I cover a different theme and each episode I go through one topic in that theme. So this month the theme is observability. So understanding what's going on when you're running your applications in containers, because that's a very different landscape than when you've been running in virtual machines or a managed service, or whatever you're currently used to, whatever your background is. Last week, which was ECS-V1, we looked at monitoring using Prometheus and Grafana to collect all these kind of metrics from all these containers that are running distributed wherever they are, and then showing them in a really friendly dashboard to give you a health check of your whole application, give you an early warning. So you're looking at for trends there for when things kind of go wrong, and then you can dig in and see what the next level of detail is. And one of those next levels is logging. That's what we're covering today. So one of the things about containers is that as you're running at scale, you're running on a cluster typically in production with, dozens of nodes or hundreds of nodes, and you're running across dozens of containers or hundreds of containers. And if you want to go and get those logs from your application to see what it's doing, like, you can't be going and connecting to servers and running the Docker logs command. That's just not going to work on any kind of level of scale. So what you do in that, and again, there's a really well established pattern for that. People have been doing this stuff for years. Is you have a kind of centralized collector that runs on all of your nodes. It scrapes up all the container logs and pushes them to some kind of centralized store, and then you use that as your central place to go and look for your logs. And that's what today is all about. We're going to be using the EFK stack, which is Elasticsearch. That's a great open source document database. That's where the logs are going to get stored. Fluentd, which is the collector component. So that's the thing that soaks up all the container logs and pushes them to Elasticsearch. And then Cabana, which is the front end that goes on top of Elasticsearch. Gets you build dashboards about, where all the logs are going and all that sort of stuff. And it lets you drill down and search individual log entries. So that's the stack. That's the typical thing people are doing when they run containerized applications in production. And that's what we're going to see today. As usual, got a whole bunch of demos. The talking head bit will finish in just a few seconds. We're going to see demos using ordinary Docker containers, using Docker Swarm and Kubernetes. The patterns are the same for all of them. The details are a bit different. So you're going to want to dig into the demo stuff if you're going to reproduce this yourself. Okay, so usual format, I'm going to pull down my green screen. I'm going to hop over there. While I do that, I'm going to run my advert, and I'll see you in about 25 seconds. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted and unrehearsed, so if you like my style but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. Okay, so that was a lot less smooth than usual because my secondary camera, the one where you should be able to see me on top of VS Code, that's not working. So that's great. So you have to just deal with the fact that I've just got my voice today. I'm still looking at the cameras if you can see me. So I'm still waving my hands around. You just have to pretend you can see me today. So what we've got here is all the usual stuff. Everything I'm doing is up on GitHub. You can go and check out the repo. Often in these episodes, I talk about like the code name for each episode, like ECS-V2. And the reason I do that is because you can search in Google and you'll find that stuff. So if I talked about ECS-V1, which was last week's episode, you'll see that I've got some of this stuff in here. There's my ECS-01 was one of my orchestration ones. So if you search for the episode name, then you'll find that stuff there, which is kind of handy. Okay, so today all about logging. So let's go and find out what we're doing today. So prerequisites, all the demos, just Docker desktop, same as usual. I'll be using that for Docker, Docker Swarm, and Kubernetes. And we're going to start with just running a really simple application. The prerequisite for any of this stuff is you have to be getting the logs from your container to start with. So your application, when you package it up to run in your Docker image, it needs to be pushing those container logs out from the standard output stream, and that's the way you're going to actually get your logs out as container logs. So if I open my terminal here, here's a really simple demo application. This is from my Docker in a Month of Lunches book. If you're watching live, I think those books are half price at the moment at Manning. So go to manning.com and you can get them half price. All this app does is it writes a log every few seconds. So it's just telling me the version of the application and then a timestamp. So it's going to write that every 5 seconds. So that's the basic. As long as when you're running your application, you can see the log entries when you're doing Docker logs, or you see them when you're running the application interactively, then you're good to go. Okay, so Docker has this kind of plugin system for logging. So if you're running natively with Docker, then you can just use the Docker plugin to direct the logs somewhere else to a different collection mechanism. And that's what I'm going to do here. So let's clear this down. So I'm going to run Fluentd. So Fluentd is the collector component. It has this whole pipeline mechanism. So you can say, these are where I expect the logs to come from. This is what I want to do with them. So you can transform the log entries, and this is where you're going to send them. So you're going to store them in a destination, which could be, a database like Elasticsearch, or it could be something much simpler. So this is a really simple way to run it to start with. Again, I'm running my own Fluentd image there. This is a multi-architecture image, so you can run this on Linux or Windows, but it just uses the kind of the published Fluentd binary. So it's listening in the background there. It's using this port 24224. That's the default port that Fluentd uses. So when you run that with Docker, when you tell your Docker containers to go and use the Fluentd logging plugin, that's what they'll expect to be able to connect to 24224. And it's the Docker engine that does this, the host. So the machine that is collecting the logs is the machine that's running the container, and it's where it's going to send those log entries to Fluentd instead of just writing them to a JSON file or whatever the other configuration is. If I look at the logs for the Fluentd container now, I get some things here about it. Shows me the configuration that Fluentd is using here, which we'll look at in just a second. And I get some things saying that Fluentd is working and it's worker 0. So that's all good. The configuration that we're using here is in this standard out configuration here. Let me close down my terminal to get some more room. And it's this is pretty simple. It's just saying that here's the source, anything that gets forwarded to Fluentd. So any logs that come in on that port 24224, we're going to match every single log and we're going to send it to standard out. And that's it. So Fluentd has this itself as a plugin model, and you can have different outputs for your log entries. It could be Splunk or Graylog or Elasticsearch or other data stores, and you can configure them on the way. But this is about as simple as it gets. So what this is saying is Fluentd is listening for any incoming application logs, and it's going to send them all to standard out in its own container. So we're going to see other application logs in the Fluentd container. So this is how this is going to work. Okay, so let's close this down. And if I run that same application again now, that same time check application, but this time I'm going to run it in the background. So I'm going to do docker run -d. So it's going to be my time check app, same application image. So it's going to work in exactly the same way. But this option here, this log driver is Fluentd. That's all I need to do. Now the Docker engine that's running this container will pick up those container logs and it will try to send them to the local host on port 24224. Those are the defaults. And I have got Fluentd listening there that happens to be running in a container. I could just be running the agent directly, but this is the container show. So when this starts running, the logs are going to be collected by Docker and sent to Fluentd. Okay, so let's just, what I'm doing on my other screen that you can't see is I'm trying to connect to my chat window because it's logged me out. So let me get that done now. If I copy that in there, Okay, so you should be able to see me now, hopefully. Oh, I've got to do a reCAPTCHA thing. Okay, cool. So now if you send questions, I'll be able to see them. All right, excellent. So this is now running. It's still writing those log entries every 5 seconds. If I look at the log entries for that container, I can see them. This is new in the recent versions of Docker. So I think this is new in Docker engine version 20.x up until 19.x. If you were using a different login driver, then you couldn't see the logs as the container logs. If you did Docker logs for the container and you configured it to use Fluentd, you would get an error message saying that this logging driver doesn't support looking at the container logs. So that's new in the latest version of Docker. But if I look at the Fluentd container, what I'll see is I'll see those logs coming from the time check application. So this is my application that's running. Fluentd is collecting the logs, and we can see here it kind of adds some metadata to them. So it adds the container ID, it adds the container name, the source, whether it's standard out or standard error, and then I get the actual log. So the log content is the same, but it's wrapped up in all this other stuff together with a more precise timestamp. So Fluentd adds its own timestamp to it. It gets some metadata from the container runtime, which is Docker, and it adds all that stuff into the logs as it's coming through. Now, my configuration here is just writing these log entries back to standard out, so it doesn't do anything interesting. But we'll see in the next demo that you can do a lot more stuff with that. Okay, so let's clear this down. So the next thing I'll be doing is I'll be running the whole EFK stack. So that Fluentd demo, that's just to show you the basics of how this works. Fluentd is the collector component. It's sat there running on your running in a container, and Docker is sending all the other container logs to Fluentd, and it's going to process them using the pipeline that's configured inside the container. Okay, so let's go and remove all the containers I've got so far. So let's go and clear everything down. So far I've just been doing ordinary Docker run commands. I'm going to switch to swarm mode, and I'll show you how this looks like when you're running in like a production orchestration environment. So let's clear this down as well. And here's the manifest that I'm going to deploy. Let's get myself some room here. I'm going to run Elasticsearch. So this is my data store component using the official image on Docker Hub with a configuration section to say this is single node. So it won't, Elasticsearch is a replicated database. It's clustered and highly available and all that stuff. But if I'm telling it just there's only one node, so it won't try and find any others. And I've got some constraints here to say that it has to run on Linux because it's a Linux image. So this is an optional thing to have. You would have this if you've got a multi-architecture hybrid cluster with some Linux nodes and some Windows nodes, and that's how you would put that constraint in there. Cabana, same deal. I'm using the official Cabana image. I'm saying it should run on Linux. The Fluentd configuration is slightly different, because I'm saying that it's a global service. So this means that one container will run on every node in my cluster. I've only got one node in my cluster, but I could use this exact same Docker Compose file to deploy to a swarm cluster in production. And what I'm saying is I want every single node in that cluster to run a Fluentd container, and it's still listening on port 24224, but it's using this host mode publishing, which means it's going directly, binding directly to the port. So it's not using that kind of load balancer network mesh that Docker Swarm provides. So it's just going to cut out some of the network hops. So every container that's running in my cluster will write to the Fluentd collector on that same node. So it's going to use kind of localhost effectively for all that stuff. Okay, so I can deploy that logging manifest. Oh, and the other thing that's got inside here is it's going to use this Fluentd ES configuration, which I'll load from a config object inside the swarm. And this is my new Fluentd configuration. So a lot more complicated than the really simple one that we've just looked at, but it starts in kind of the same way. Here's my source. I'm listening on port 24224, and any logs that come to me are that's the source of my logs are going to be anything that gets sent to me directly. And then I've got this filter that says anything that comes in, I'm going to run through this transform. So Fluentd has this pipeline. I can put in these transformation steps to enrich with some extra metadata or to change some of the data that's coming through. And what I'm saying here is for each record, so that's for each log, I'm going to add these metadata items, application name, service name, and image name, and that's going to come from this tag. Now, Docker applies that tag. So in my application config, I can say, here's the tag that you should send to Fluentd when you send every log entry. And then when it gets to Fluentd, it'll pull apart that tag, and it'll use each item inside the log tag as a piece of metadata that gets stored with the log entry. Okay, so that's the kind of transformation stage. So I've received my log entry from Docker. I've done my little bit of processing, so I'm pulling apart that tag into separate metadata items, and then I'm going to store everything. So this match again is so I could have different destinations for different types of logs for different applications in my cluster. I'm saying match everything. We're going to copy them to Elasticsearch, and you'll find Elasticsearch running locally on the cluster using the Elasticsearch DNS name, and a few other bits and pieces here just to say what format we're using, whether we include the tag, all that sort of stuff. So this is saying we're going to take everything that we come in, we're going to enrich with some extra metadata, including the image name and an application name, and then we're going to store them all in Elasticsearch. So the configuration language takes a little bit of getting used to, but the pattern is going to be the same for kind of whatever you're doing. The only real difference is you might have multiple match blocks sending, some of your urgent log entries get sent to Elasticsearch, and others just get stored in a file somewhere, or whatever you want to do with your log entries. Okay, so that's my configuration object. So let's open my terminal again here, and I will create that config object. So that's just taking that same configuration we've looked at and storing it in the swarm. And I'm going to deploy my logging stack. So again, just like we did with Prometheus in the previous episode, that logging stack is going to be a subsystem effectively. It's going to be a separate bunch of components that all my other applications in the cluster can use. So I've created this logging network where Cabana and Fluentd and Elasticsearch are all going to be talking there. And in the Docker model, any containers that I run with the Fluentd logging driver set up, are gonna push everything to that same kind of logging central subsystem. Okay, so let's clear this down, have a look at the services, make sure they're all running. So everything's up and running, so that looks good. If I look at the logs for my Fluentd container, then I should see all the usual stuff. I'm going to get some messages about Elasticsearch. Up here, if I scroll long enough, I'll see all my configuration, which has come forward. It gets mapped by what we've got inside here. That doesn't look like the right configuration, so let me just make sure I've got this correct. Let's go back to my logging setup here. Obviously, I did test all this before I ran, so that looks good. Fluentd es.conf. Yeah, that looks okay. The Fluentd conf is fluentd-es.conf. Okay, well, let's see what happens. So the Kubernetes demo is the best one anyway. So let's get rid of this logging thing here. And let's just do a docker ps. So even though I'm running in swarm mode, because I'm connected to my manager node, which is where everything is running, I can do a docker ps and see the individual containers. And this, if I look, this is where I'll see that my Fluentd container is binding to port 24224. So any log entries that Docker collects and sends there will get picked up by Fluentd. Okay, so if I open Cabana, Cabana's up and running here, so it doesn't have any, won't have any application data in there at the moment because I'm not running any of my own application containers, but I can connect to Elasticsearch and it's already got some data in there. So I can go and browse to, let me zoom in a little bit here, create my index name of Fluentd, and it will find my index that's there. So Fluentd is already collecting logs and sending them to Elasticsearch with the timestamp, so I can filter all this sort of stuff in the way that I would normally with any data that I'm putting in Elasticsearch. And if I go and click on the Discover tab now, I'll see some entries coming through here. And these are from Fluentd itself. So Fluentd's own logs are going through that same pipeline. The image name doesn't know because we haven't set that up inside the Fluentd configuration, but it still passes that through as an empty piece of metadata. And then I get my message saying it's listening on port 24224. So some of those logs are already kind of flowing through. Okay, now if I deploy my application, let's close the terminal and have a look at my time check application. So it's the same Docker image. I'm not doing anything kind of particularly interesting there. It's that same time check image that just writes a log entry every 5 seconds. I'm trying to model that how this would look in a real application. So the application itself might connect to a network with other components, but it also needs to connect to my logging network if I want to be able to send things directly to Fluentd. But my Fluentd driver this is happening at the host level. So the Fluentd driver is going to use the default options of localhost and port 24224, which is where my containers are listening. And here's where I put in that tag. So I can put in some specific data here. I can hard code the fact that this is my time check application. The component is the publisher, which is just a name that I made up. And then Docker will supply the actual image name. So when the log entries get sent to Fluentd, it'll have the content of the log message plus this tag, which will be timecheck.publisher.imagename, which is what goes through the Fluentd pipeline, gets pulled out to show you the actual image name. Okay, I'm running 3 replicas, and again, I'm constrained this to run on Linux in case I was running on a multi operating system cluster. Okay, and that's all there is to that. So let's close this down. And when I deploy this, we'll see if I've actually got my Fluentd configuration correct. So I'll do a docker stack deploy using that timecheck.yaml file. It's going to create a separate network, run my containers in there. If I look at the timecheck stack, I'll see my containers. They're all up and running. It's a super lightweight image, so it doesn't take long to get things started. If I look at those logs, I'll see they're all coming through. Okay, that's good. And now this is where we go to see if Cabana is actually, Fluentd is actually doing what I expect it to do. Oh yeah, okay, that's looking cool. So it did load the correct configuration. Just when I looked at the logs, it kind of threw me by showing something completely different. So what I've got here, if I look at my application name here, I've got Fluentd. And I've also got my time check here. So that's coming through from the tags. So this is the reason for having this metadata, is that now I can filter based on these tag values. So I can filter just the time check applications and it'll get rid of any of the Fluentd logs. And when I'm inside here, like I can open these up. I'm getting all that low-level detail about the image name that's coming through, the application name that I provided, the service name, which came from my Docker Compose file. And then I get the actual log entry telling me the timestamp. But also I get those other things that Fluentd picks up. So I've got the container ID, and I've got my, somewhere in here, I'll see my container name, which tells me the number of the replica that's running. So that's timecheck.2. If I scroll down here, I'm going to see timecheck.1 and timecheck.3. So they're all writing logs. They're all being collected by Fluentd and sent to Elasticsearch. And if I deployed these same stacks on a 100 node cluster, then the output would be the same. The containers would be running on different nodes across the cluster, but the behavior is the same for all of those applications. This centralized logging component is scooping up all the container logs, sending them to Elasticsearch, and this is what I can then query in Cabana. So you can imagine if I got an error message from a user, I can put that inside here and it will show me everything. You can also build dashboards here, so I can have a nice little set of graphs for each component showing me, the number of logs of each type. So if there's a sudden burst in error logs, I can go and drill down and check that stuff out. So this is the kind of goal we want to get to. This is how you do it with Docker Swarm. It's a very similar approach in Kubernetes, but the mechanics are slightly different. So what I'm going to do is I'm going to wipe out everything we've got so far. So I'm going to remove my swarm, which will get rid of all my containers that are currently running. And I've got Kubernetes running already in my Docker desktop deployment. So it's all up and running there. It's currently kind of empty. So if I now do a Docker PS, I should see that I don't have anything running, which I don't. If I look at my nodes to make sure I'm connected to the right cluster, and I'm not accidentally deploying things on my live cluster, which kind of happens most weeks. That's Docker desktops. That's all looking good. If I look at the namespaces, what I'll see is the kind of default set of namespaces. If you're new to Kubernetes, then namespaces is just a way of partitioning, or can be a way of partitioning your workloads inside your cluster. We've got the system level namespace, which is where all the internal Kubernetes components run. The default namespace, that's where you're going to deploy your apps unless you specify a namespace. And we're going to deploy that same EFK stack with a couple of variations. We're going to use Fluent Bit, which is an alternative of Fluentd. So it's just an alternative collector component. It works in a very similar way. It was originally designed for lightweight kind of IoT scenarios where you don't want a big binary sat there collecting logs and forwarding them. You just want something really simple and lightweight. But it works in a very similar way. So it fits really nicely with Kubernetes because same approach. I'm going to run a collector component on every single node in my cluster. So I want it to be the most lightweight thing that I can get. So then in that case, I might as well use Fluent Bit, which has good support in Kubernetes as well. It also supports Elasticsearch as a destination. Fluentd has a lot more integrations than Fluent Bit. So, some of the things you want to do, you can't do in Fluent Bit. But if you can, then it's a nice option to have. And here's my configuration here. So Fluent Bit has a slightly different way. Let me close my terminal. Slightly different way of defining the pipeline, but the pipeline itself kind of works in the same way. Let's open this up so we can see. This is the interesting thing. So it splits down into like the input level, which is where in Docker we said we're listening for any input coming in on this port. So the input was the network traffic from the Docker engine. There's the filter configuration where you can kind of do any enrichment you need to do, and the output configuration, which specifies the destination. Now in Kubernetes, the container logging is slightly different because it doesn't have a plugin system as such in the way that Docker does. So I'm not configuring my Kubernetes pods to use a particular logging driver. Kubernetes always collects container logs and stores them as files on the node. So the node that's running those containers, the container runtime is just writing out logs in the same way, and Kubernetes is storing those in JSON files. So that JSON file for each container has a kind of standard format. So you can use a kind of ugly regular expression to break up the pieces of the name of the .log file name. That's where all the log files are going to be stored, and work out the namespace, the container, the name of the pod, and even the container ID. So this horrendous bit of regular expression here, that's going to break up the file name and get me all those pieces, which I can put into my metadata. In the same way that we got the service name and the image name from the Docker tag, we're getting as much information as we can from the Kubernetes log file name, which contains all the kind of basics of where those logs came from. So we're using this tail input, which says read some files. It's going to look at all the star.log files in that path, which is where Kubernetes runs everything. And then it's going to use this regex to take apart the file name to get some tag entries out there. And then in my filter configuration, I'm using the Kubernetes filter, which is a built-in thing. So it understands about getting more metadata from the information that it's got from Kubernetes. And then in my output configuration, I've got 3 sets of outputs. So I'm doing this by the namespace. So I'm saying that anything that comes from the Kubernetes kube system namespace, we're going to send it to Elasticsearch, and we're going to send it to the sys index. So Elasticsearch, you can store your documents in different indexes, which are just a collection of documents. So all of my Kubernetes system ones are going to go to sys. Anything that's from the logging namespace, which is where I'm going to deploy Fluentd itself, that's going to go to the logging index. And anything that's in the default namespace, I'm going to send to the apps index. So when I've got this running, I'll still have that idea, that same concept of having a logging subsystem within my cluster where all the application logs are going to get collected, they'll all be processed, they'll all be stored in Elasticsearch. But I'm using this pipeline slightly different pipeline to break things up and put them in different places. So I could use, different, completely different output types. So that my output type here is always Elasticsearch, which is built into that Fluent Bit container that I'm running. But I could use different sources, different destinations for different sources. So my system things could just go to a file somewhere, and my application logs could go to Elasticsearch. Okay, and the last little thing in there is these parsers, which are what help Fluentd understand the format of the log entry. So everything that comes in is going to be JSON because it's all coming from the Docker logs. Ultimately, that's all Kubernetes does. Is it scoops up the logs from the container runtime, stores them as log files, and then Fluentd will come in and take them to pieces. Okay, so that's the configuration that Fluent Bit is going to be using. And then Fluent Bit itself, we're going to run it in a similar way that we did in Docker Swarm. There'll be a single Fluent Bit container on every node. The way you do that in Kubernetes with the daemon set. This will run across the cluster. It's using the official kind of Fluent Bit container image from Docker Hub. I'm mounting my Fluent Bit configuration that we've just looked at, and also all the container log paths that are from the host. So these are coming from host paths. So you need to make sure that you've got access to be able to look at those paths, and then the Fluent Bit container will read those log files from the host. So it's just mounting that volume directly from the host disk, and then it will process any new log entries that come into those files. So also the Fluent Bit, in order to get the additional metadata, talks to the Kubernetes API. So for that, I've got a custom service account, a custom cluster role with just the level of access that Fluent Bit needs, which is to get, list, and watch namespaces and pods. So if you're doing anything that talks to the Kubernetes API, you need to get your RBAC, your access control configuration, nailed down so that the pods can't do anything more than they need to do. Okay, so that's what we're going to be putting in there. I've also got, if I look at the folder here for Demo 3, I've also got Cabana and Elasticsearch deployed, and they're going to be running in their own namespace. They're going to be running in their own logging namespace where everything, that's kind of my logging subsystem. Okay, so let's close this down, close that down, open that up, go back to my README here, and let's clear this down. So I'm going to deploy everything from that logging folder, which is going to be my Fluent Bit config map with the pipeline defined, Fluent Bit itself, the daemon set, and then my Cabana and my Elasticsearch services and my deployments for those. It doesn't matter where on the cluster they run, but for Fluent Bit, everything will run locally. So let's clear this down. And so each Fluent, in a larger cluster, I would use exactly the same configuration. And then each Fluent Bit container is reading the log entries from its node, and then all the Fluent Bit containers, one on each node, are sending the log entries to the central Elasticsearch database. In production, I could use, a replicated Elasticsearch with, highly available storage, or if I was in the cloud, I could use a managed Elasticsearch service. So I've got lots of options there for high availability and all that sort of stuff. Okay, so let's have a look at the pods that are in my logging namespace. So I've got Elasticsearch, that's ready, Fluent Bit, and Cabana, so that all looks good. And if I look at the logs of my Fluent Bit container, I should see a whole bunch of stuff, all about errors connecting to Elasticsearch, but that was from 30 seconds ago. So Fluent Bit container has started at the same time as my Elasticsearch container. Elasticsearch takes a few seconds to initialize, so I'm getting all these errors, but they've stopped. So if I look again, there's no more new errors there. So it's connecting to Elasticsearch now, and everything should be fine. Okay, if I browse to Cabana, I'm using a different port for this time, but it's a completely separate Cabana instance, but it's using the same image, and so it's going to behave in the same way. I can connect to my index, and I've already got these two indexes in here. So those, the pipeline that I defined to pick up the Kubernetes system component logs and the logging namespace itself for Fluentd, they're already in there. So if I take sys here and put that in as my pattern, I'm going to put in my timestamp, and I can create this. And because all these documents are already being created, these log entries are already in there, Cabana knows about all these things that are in Elasticsearch. And so I can create my index pattern here and go and check it all out. Oh, I've clicked the wrong one. So here we go. Here's my system index. And everything I've got in here is coming from the Kubernetes kube system namespace. So that's things like the Kubernetes API server, DNS, any other kind of core components that are in here. I'm getting the same kind of thing. So I get, I get the log entry itself, which should be way down here somewhere. Something to do with etcd doing a compression of its data. I've got the timestamp, I've got the stream that it came from. It tells me the pod names. There's my Kube API server. I can see the namespace, the tier, the component, all these labels that come through. So any labels that are applied your Kubernetes deployments, that comes through too, along with this other metadata that Fluentd picks up. So the container ID, container name, and the container image. So I can get a whole lot of low-level detail as well as the actual logs themselves. If I go and look at, can I expand this a little bit? Obviously not. So let's instead zoom out just for a second. All these annotations here, all these labels and these tiers, I can see the host of so if I had multiple servers, I would see them all coming through inside here. And then this tells me this is etcd. I'm getting my Docker desktop VPN kit. I'm getting the controller manager and the API server. All those logs are all in the same kube system namespace. They're all coming through in the same way. Okay, so let's clear this down, and we can deploy my application in the same kind of way as well. So now if I open my application manifest for my time check app, so again, I'm using that same image. There's nothing special here. This is about as minimal Kubernetes manifest as you can get. It's a deployment, so it'll run a replica set, which will run a single pod. The pod's going to use that image. I've got some labels in there to give it an application name and to identify it as this episode of the show. And that's it. There's nothing to do with logging in there. I'm not specifying a logging driver like I do with Docker Swarm. I'm not specifying any log tags, anything like that. That's all kept central. So in the way that the Kubernetes way of using the centralized logging is much neater, because those logging concerns don't leak into your application model. So my application model just says, here's the container that you're running. The cluster itself decides what to do with the logs that come out of that container. So that's a pretty neat way of doing it. Okay, so let's go and deploy that application there. And again, it's a really, really simple app, so it should start logging and running really, really quickly. Let's just check if I get my pods. There's my time check pod. It's been running for a few seconds, so I should get some logs through. Let's go back to Cabana here, and let's add a new index pattern. So create my index pattern. So it's the app's index is already there. So this is the other part of that pipeline. There's one pipeline in Fluentd, but it's got different branches depending on where the source of the data is from. So anything from the default namespace will go into this app's index here. So it's creating those inside Elasticsearch. And that's just a name that I've chosen to make it clear that they're different from the system logs and the logging subsystem logs. So again, I can put my timestamp in there. It's going to create my index pattern. If I go back to Discover and select that applications index here, then I'll see a whole bunch of stuff coming through from my time check application. Like before, if I look at the app label, I can see the labels that came through, my ECS label. So anything that I put in as metadata, either as labels or annotations, they will come through here into my log entries. And then each log entry here, if I scroll down, it's the same stuff. So there's my time check, the application version. I've got the pod ID in here and the pod name. I've got the template hash, so that tells I can link that back to the replica set. The image that started it, and the image hash. So I've got the actual SHA hash, so I can specifically identify which image this container is running from, without any kind of, without any worry about it being a different tag with different content. So I can get exactly what's running, and all my log entries are coming through. I didn't do anything in my application manifest to make that happen. Everything just flowed through into my logging subsystem in the same way, just because it's set up for anything in the default namespace. So likewise, we'll run that same astronomy picture of the day application, which you may or may not be a fan of, which I use quite a bit. So 3 components here. There's a kind of REST API. There's a access log API, which records how people use the app. There's a web application. They're all written in different languages. They're all using different configuration mechanisms, but they all have that basic requirement that the container, the application logs come out as container logs. So now in my default namespace, I've got my time check pod. I've got my web application. I've got my access log. I've got two pods for my my Java API, and now I can go and browse to this application. And this is the first time I access it. It goes off to NASA to get some information about the picture of the day. This is today's picture, which at a push, you could say these set of constellations vaguely mirror what this guy is doing here. But that information is all coming through in my application components here. If I refresh this a few times, we should the data now should come from the API, which should come from my cache. So I can do that and see what's going on here. Now, if I go back to Cabana and refresh, let's zoom in a little bit here. Now in my application labels here, already I've got my time check app coming through that we had before, but I've got my APOD API and my APOD log. So those are the 2 components that are writing log entries that are being collected. And if I go and filter just on the API, by clicking that tiny button there, and if I expand this and go and look at the log entries, I'm seeing that we fetched the new image from NASA. So those are my raw log entries that are coming through. I've got all that other metadata, same as usual. This is just a text log, but if I had a structured log entry, so I knew that, actually this is what I've got here. I've got the timestamp that the application sees, the logging level, the component that generated the log, and the log message. I could put an additional parser inside my Fluent Bit configuration to say, when you get logs from the Java API, actually break these things out. Again, using some horrendous regex to say these are the different fields, and then I would be able to filter again. So anything that I can raise to the level of an individual field inside Elasticsearch, I can then filter on and search on inside Cabana. So I could have the logging level elevated as a field, so promote it as a field rather than just a piece of text. And that would make it a lot easier to work with these logs. But as the basic kind of entry level, if you get text out from your container logs, then you can store them and work with them like this. You've got full text search here with Elasticsearch and Cabana, so you can always drill down into things. But if you've got consistent structured logging coming through, you can pull the pieces out into different fields, and that makes it easier to work with, especially as you're using more and more components in your logging. Okay, and that's about it. So everything's up and running. Everything's been labeled, so I can just kind of remove everything there. And then next week, we're going to look at distributed tracing with Jaeger. So what I'm going to do, which is different from normal because my camera's failed, is I'm going to switch back to my talking head. So this is me here. So I hope that was useful. So that was all about logging. We looked at Elasticsearch, Fluentd and Kibana. That's the kind of main stack that people are using. It's all open source. Fluentd is a CNCF project. Elasticsearch and Cabana have come from the Elastic company, who also provide a service, like a product, to manage those things as well. They've been around for a long time, really solid components that, again, you can use all the open source versions, drop them straight into your application, and get like really good feature set like the one we just looked at with very little effort. Next, we're looking at open tracing. So the idea of tracing is that I've got a distributed application with lots of different components, and it would be great if I could record how long each component spent doing some part of a transaction, and then get a view overall of, the response to the user took 5 seconds because we've spent 2 seconds in this API and 1 second here and 2 seconds waiting for some third party. So that's what open tracing gives you. Jaeger is the component that helps you kind of pull everything together and gives you the UI to look into those logs and drill down into the time components. And that's what we'll look at next week. I'll make sure my other camera's working so you can see me while I'm doing my demo. So I hope that was useful. My name's Elton. You can check me on Twitter at Elton Stoneman to find out when the next episode is coming. It'll be next week, and then the week after that, I think we're looking at sidecars. So I said at the beginning of this episode, the kind of prereq is to get containers out from your logs. We saw last week with Prometheus that you need to get a metrics endpoint, an HTTP endpoint being published from your logs for Prometheus to go and collect from. Not all of your applications have those things. So next week, we'll look at tracing, and then we'll round off observability by looking at applications that don't fit the model, that don't produce logs in a useful place, don't have their own metrics endpoint, and we'll look at how we can extend application containers with additional features without changing the application code. So hope that was useful. Hope to see you again.